Right guys, so in today's video we will create a iceberg move right here with some cool particles, and we are going to start off in Blender with the creation of this iceberg right here. So as you can see in the left bottom corner, you can see my inputs. Alright, so I'm not going to explain how you can use Blender. If you're not familiar with it yet, then watch some other videos to get familiar with it. I'll only blend in those inputs right here. And yeah, so I'm gonna mute myself. I'm gonna speed up the video, at least I think so. I'm gonna be back once this iceberg model is done. Alright, so this is our mesh right here. Let me apply all of these right here. Okay, so this was shaded smooth. I'm gonna add split right here so that it looks like this. And now go to File, Export OBJ, and export this as an OBJ file. And then I'm gonna create one more mesh. And then we'll see each other back in Roblox Studio. Alright, so what this mesh is going to be about is that this is going to be an ice block which we will spawn, or yeah, an ice block which we will spawn around the character once the character has been hit by this iceberg right here, alright? So go to File, Export, OBJ to export this as an OBJ file as well. After this, we will not directly switch over to Roblox Studio, but we will switch over to Paint.net because we will create some particles in there. Alright, so this is not going to be a Paint.net tutorial either, so if you're not familiar with Paint.net, then get familiar with it. I'm not going to explain anything right here. I'm just going to create those particles and then show you how to save them. And then after that, we will switch over to Roblox Studio, guys. Alright, so I have created two particles right here. This one is going to be some kind of trail, let's say. And it will also appear when the ice bird breaks, let's say, so when it hits someone. And those are going to be little splinters, I think. That's the term for it, yeah. Some small splinters right here. And yeah, so if you want to export those, go to File, Save, and then Save as a PNG, alright? And do that for both of them. Then we will see each other back in Studio. Alright, so back here in Roblox Studio, the first thing which we want to do is that we want to import a mesh port right here. No insert, and then we want to import this iceberg. So I'm gonna import this by clicking on this folder icon right here. I'm gonna pause the video. So this is our iceberg right here. Iceberg. Yeah, let's design this a little, so... All right. Weld this iceberg part, this second one right here. So if you're doing this as well, then weld this. No, wait. Part 0 is this one. Then weld this onto this main iceberg right here. Make sure that both are can collide faults and anchored faults as well. And we also want to add a part right here. And let's add a particle inside of here. Particle emitter. And let's size this right here. There we go. So, left wing. Make sure it can collide as faults. Make sure that it is transparent. And put a weld constraint inside of here. Nah, come on. To weld this thing. So part 1 becomes this one. To weld this onto our main bird right here. Now let's deal with the particles right here. So we do not want this to go to the top, but to the back right here. That's the first thing which we want to do. Ah, come on, my god. Yeah, let's do it like this. Yeah, like this. Yeah, there we go. Okay, let me import my... Where is it? My image, alright? So I'm gonna pause the video. Alright, so the first thing which we should do is we should, first of all, change the color so that it matches. Alright, there we go. Now it does match, more or less. Next thing which you want to do is that we want to decrease the rate heavily because this is just too much. Let's decrease the speed as well. Let's decrease the lifetime right here as well. The rate is still too much. Alright. There we go. There we go. All right. Let's duplicate them and let's add the second image I had. All right, so here we go. So what about this one? So those should be smaller. Yeah, that's actually fun right here. So let's keep it this way, all right? Let me clone this one and let me make this a right wing. There we go, right wing. And make sure to weld this thing correctly, so... Okay, it already is welded correctly, that's good. So, here we go, this is our ice bird model right here. And we will now hopefully script this. But before we continue, let me add another mesh pod. And we will now import our ice block, which we have created as well. So I'm gonna pause the video and import this one. There we go, so this is our ice block. All right. So ice block 2. So we might add some particles inside of here as well. Let me first of all add a weld constraint so that we weld everything to each other so that they do not fall off or anything like that. Let me copy this. Let's hope that this is the correct one. Right. There we go. So those are our two assets right here. Make sure that the ice blocks also can collect faults and anchored faults as well. And here we go. So move them inside of the replicated storage. And we'll now start the work on this one. Alright, so the first thing which we are going to do is that we are going to import this tool right here. Make sure that requires handlers faults, alright? So next thing, let's call this one Icebird. And let's put a local script inside of here. Inside of this local script, we want to put a remote event, and inside of this local script, once again, we want to put a script, alright? So let's call this one client. Let's call this one server. And let's call this one remote right here. Right, so inside of this client script, what we want to do is that we want to do script parent activated connect function. So what does this mean? So script.parent, so you can imagine that script is this one. Dot parent refers to the tool. Dot activated refers to an event, which happens when you have equipped the tool and when you have performed the left mouse button click, alright? So when you have performed the left mouse button click while having the tool equipped, we want to fire server this remote event right here. So script remote fire server. Let's call this one Icebird, alright? So let's go inside of the server script and let's refer to the remote event because we want to check whether this has been fire servered or not. And we want to get all of the arguments inside of here, alright? So script.parent, so this time script is server script, alright? So because we are scripting inside of the server script right here, so script becomes the script you're currently scripting inside of. Yeah, script parent refers to the client and then remote. Remote, so script parent remote. And then on server event, as I've already told you, is the event which happens when this remote has been fire servered. So when it has been fire servered, what we want to do then is that we want to first of all get all of the arguments. So the first argument which you always receive, regardless whether you have put anything inside of it or not, is the player, alright? And then those arguments right here follow. So the first one, second one, but we do not have a second one right here. We only have one. Therefore, can get rid of this. So if arg stands for argument equals Icebird. So if the task is to do the Icebird, then we want to do the following. So we want to clone this Icebird model right here. So local x game get service replicated storage wait for child Icebird clone x parent workspace. That's the first thing. Second one is that we want to adjust the C frame right here. So local C player.character. There we go. So the C frame becomes our humanoid root parts. C frame multiply it with a random C frame. No, not a random one, but with another C frame right here. Alright, and let me actually keep this anchored just for the beginning to see whether or where the bird lands when we spawn it. Okay, right in front of me. That's good. That is good. Let's actually increase this. There we go. And yeah. So what we want to do next is that we want to delete this. No, we want to set this to false. And we want to create a body velocity, alright? So what does this body velocity do? Although it is deprecated, there are other ways to move your object right here. We are still using this one because I haven't really figured out what kind of alternatives there are. So body velocity makes your object move, alright? So that, yeah, that's basically it. So there is nothing more to say to this one. So we have to tell the force, or we have to give out the force, which is going to be huge. So, and the velocity itself determines how fast your object is moving and where exactly. We can do this by referring to our humanoid root part C frame, and then look vector basically gets the direction we're looking at, and then you can multiply this with a number, and the higher the number is, the higher the intensity, or the higher the speed of, or the velocity will be, alright? So let's keep this at 30 just for the beginning. Let's see what this does. Okay, what happens now? Why isn't this working? Ah, right there. Wait. Wait. Alright, there we go. So now the iceberg is spawning in front of us, and we are also able to spam it, but we can get rid of this later on. Alright, so that's how you spawn objects, alright, that make them move in front of you. Now what we want to do next is that we want to see whether some players are in front of us, which would be hit, you know, by this iceberg, and then put them inside of this ice block and deal damage to them. So how will this work? So we're going to make use of ray casting right here. So raycast params, got new ray settings, filter type, and then blacklist, ray settings, filter descendant instances, is going to be C right here, but also let's put it down here then, but also X. So I'm gonna be explaining this in a bit, do not worry. Ray workspace, raycast, C humanoid root port, position, all the way to C humanoid root port, C frame, look vector, multiplied with 30, and ray settings. If ray, then print ray instance name. So let's test this out before I explain what this is about. Alright, alright. Right, lower arm. Part. Alright, so let me explain how this works, alright? So, when it comes to raycasting, you can really imagine something like this, alright? So let's take this part and let's pretend that our character stands on this gray part right here and looks into this direction, alright? So let's pretend that this is the case. So we have now set up a ray, alright? So what is a ray? You can really imagine a ray something like this, or at least I do so, alright? So a ray is some kind of line right here, alright? Which has a starting point, which is defined right here, and which has an ending point, alright? So the starting point is our position, and the ending point is the direction we're looking at, multiplied with 30, alright? So wherever that might be. So imagine that this is your starting point, and let's pretend that somewhere right here is our ending point, alright? So everything which touches this part now has intersected with the ray. So pretend that this part is your ray, and everything which touches it, so every part whatsoever, intersects it, and this causes, or this triggers this thing right here, alright? So we have now set up some ray settings first of all. And this is just some kind of template, alright? So raycast params, and so raycast parameters of think new. So we have created a new template, which is now being filled with settings. The first setting which you would like to change is the filter type, which is then being set to blacklist. So we are basically blacklisting some stuff so that they won't be, or they won't trigger this statement right here, alright? And the instances which we filter, they are inside of here. So C is our character, so our character is not a trigger of this ray, and this bird right here is not a trigger as well, alright? Now, we are right here setting up the ray, so you have to refer to the workspace and then do raycast, and then as I've already told you, you have your starting point, your end point, and then the third argument are those ray settings, alright, which we have just adjusted right here. And if ray means when the ray was intersected, when someone has touched the ray, or something has touched the ray, then as for now we're just printing out the name of this thing. So ray.instance is the part which has touched or intersected with the ray. Alright? So that's basically it for this one. We now want to make sure that the part which has touched the ray is an enemy. Alright? So someone we can deal damage to. Because a ray could possibly also intersect with something like a tree or a wall, but there is no point in freezing them, alright? So how do we do that? We want to check if ray.instance parent contains a humanoid, alright? And this is basically it. You don't need to do anything more. So my previous videos, I have like 3 requirements which have to be met in order to say that the part we're currently having right here is a body part and belongs to a potential enemy, or belongs to an enemy. But in this case, we only need 1 requirement, and let me explain you why. So the first requirement I always do in my previous videos is that the parent in this case is a model, right? We could actually add it inside of here as well, but this is not needed because the second argument, whether the model in which this part is inside of contains a humanoid, already tells us something about the first requirement, alright? So a character model usually is a model itself, but also has a humanoid inside of it. So if you're able to find a humanoid, then you can conclude that this has to be a character model, alright? But if we would only assume that keeping the first requirement is enough, and not having the second requirement right here. So the first requirement, just to quickly remind you, is that whether ray instance of parent is a model, alright? But assuming that just because you have a model, you have a character model, is a wrong conclusion, alright? Is a wrong assumption, because you can also have some models which, you know, which hold parts for a tree or a house, and they do not need to have any humanoid inside of there, alright? So therefore the second requirement, whether a humanoid is there, is crucial and is very important, because this tells us a lot about the enemy we are facing. So there is a humanoid, and humanoids are usually stored inside of a character model, therefore we do not need the first requirement. And my third requirement usually is that Ray instance apparent, the name does not equal our player's name, but this is excluded as well, because we are already filtering out our character from this ray, you know? Therefore, it will not happen that our character has touched the ray, alright? And this is it. We can now deal damage to this one. And we can freeze this character right here as well, so we are going to do that now. As you can see, we are able to deal damage right here. Now we've messed up, I think. Now we do not. So how long is 30? Multiply. Yeah, wait. What is the range actually? Okay, so this is what happens when you multiply with 30. Alright, look, so before we move on with freezing the enemy, I would like to clear this up. Add item. Let's delete this after 4 seconds. Let's increase this to 50. And let's move on with freezing the enemy right here. Let me define a variable first of all, which refers to the enemy's humanoid report, so that we do not have to fully write this out every time. So enemy hum, take damage 10. That's the first thing. Second thing is that we want to make sure that the enemy is not able to walk, but actually, instead of setting walk speed and jump power to 0, we can just freeze the enemy by setting anchor to true, alright? And then we want to clone this ice block right here, so we have to refer to the replicated storage and then wait for child, ice block, and then we want to clone this one and we want to parent this to the workspace. Make sure that this is anchored, alright? So that's important. So anchor this thing. And we want to C-frame this to our enemy hum. Enemy hum, parent, humanoid, root part, C-frame. There we go. There we go. So we have just freezed this one right here, and this one has also received damage. Now, when you want to unfreeze this guy right here, after a certain amount of time, what do you need to do? So, let's add a tween actually. So, local T, game get service, tween service, create, x2. We also, no, we really need to create 2 tweens at this point. I'm gonna explain to you why soon. So, it's after, let's say, 5 seconds. And then easing style linear, and then come on, and easing direction out, x2, come on, oh my god, x2, nah, wait, transparency to 1. Now we have to set up another tween. So this tween right here, what it does is that it turns the transparency to 1, means to transparent slowly, alright? So within 5 seconds, okay? But this only applies for X2, which is basically ice block, so this part only. But we haven't covered up this part, alright? So in order to cover this up as well, we have to clone this tween. And instead of referring to X2, we have to refer to X2 ice block 2. Alright, But since they start at the same time, they also complete at the same time. At least I think so. And therefore we can just do this event once. So this event tells us whether this tween right here has been completed, and if it has been completed, means the ice block has fully turned invisible, which also means that the ice block has melted, alright? So that's basically this kind of illusion we are creating. So if the ice block has been melted, has melted down whatsoever, then we want to make this, or we want to reverse this one. So we have just anchored this this part which has intersected our array. So we have anchored this one right here. We want to unanchor it. And after that, we want to delete x2. And this is it. So what I would like to do as well is that I would like to randomize the amount of damage which is being received right here. So random number between 10 and 30 is being selected right here now. And one more thing I would like to do is that I would like to play an animation, alright? So let's create an animation inside of here. So this animation is going to be pretty easy, so nothing too special, but it just appeals more to this overall design right here. So right, so this might be a little bit too slow, but yeah, now it is okay. Make sure to set the animation priority to movement. That's very important, so that the parts we haven't touched, means those ones and this one, that they just adapt to the idling animation, and that only those parts which we have now edited, that they only move, alright? So you'll probably understand what I'm trying to point out right here once you've seen it. So Icebird Anim, submit this one, copy the ID, that's very important, and then go down here and put it inside of this animation right here. Alright. Next thing which we want to do is that we want to load this one. So see, humanoid animator. So there is an animator instance inside of the humanoid, which is responsible to load all of these animations. And we want to load our animation right here as well. So inside of this load animation function, all you have to do is that you have to refer to the animation you're trying to load. In this case, it is this animation right here. So script, command script the animation, alright? And then you want to play this one. And down here, wait, now we cannot really sense what this has been stopped or not, right? I think that we do not even have to stop this manually, because when it is completed, it just stops automatically, alright? So that's fine. Let's go inside of here and let's quickly add a cooldown, alright? So create a variable and call this one cooldown, okay? So I'm gonna explain cooldowns once again right here. So that's the first thing. Now, every time when this tool is being activated, you want to check whether cooldown is false. That's important. And cooldown is false by default. That's important. So when you when you join the game and when you activate this tool right here, then cooldown is false by default, which makes this requirement right here to be true. And then you move on with this part right here, alright? Now, passing this check right here will lead to this. So to setting it to true. Now, when this has been set to true, then after completing this and after reactivating it once more, you will fail this check because cooldown is now true. That's basically how cooldowns work. Now, you can wait a specific amount of time. Let's wait 2 seconds. And after those 2 seconds, we want to make cooldown false again. And those 2 seconds are your cooldown time, okay? That's it. That's all about cooldowns. We have forgot to make the stream play. Yeah. We have forgot to make it play. Yeah, we did. So T play, T2 play. There we go. Alright, now we are pretty much done, I think, with this video. So, as you can see, the ice slowly melts down and our enemy right here is free again. And yeah, so this is it for the video, guys. I hope you have enjoyed it. If so, leave a like, subscribe, share this video to all of your friends, and leave feedback in the comment section, guys. Take care and see you in the next video, my friend.